Okay, so 2.1e lesson begins on page 27 in your module. So everybody should be on page 27. You should have your pencils ready. And we're going to take a look at subtraction and integers review. So for numbers 1 through 6, they ask us to circle the operation we're going to perform and draw a chip model for each. And of course, we want to state the sum or difference once we have our model to look at. So for number 1, I'm going to circle the operation we are subtracting. And if I'm drawing a chip model, I'm going to start off with a positive 5. So 5 unshaded chips. And remember, if I'm subtracting 3, that means I want to remove 3 positives. So I have plenty of positives, and I can remove 3 of them. And from my model, I can see that 2 positives are remaining, so my difference is positive 2. For number 2, I'm adding 5 and negative 3. So just like number 1, I start with a positive 5, so 5 unshaded chips. But for addition, I'm going to add on to my model, and in this case, I'm going to add negative 3, just like the expression tells me. When I add negative 3, I can see that 3 zero pairs are formed, and all that would be remaining in my model is a positive 2. So the sum is 2. For number 3, we're back to subtraction, and I'm starting with 2 positives to represent the first integer 2. And I want to subtract 6. So the problem is I only have 2 positives. If I want to subtract 6 positives, I'm going to have to add 0 pairs. If I already have 2 positives, I really only need 4 positives. So I'm going to add 4 0 pairs. And remember what this means. By adding 4 0 pairs, I've essentially added nothing. So my model still represents positive 2. But because I've added those 4 0 pairs, I now have 6 positives that I can remove and finish my model. So now I'm going to take away 1, 2, 3, 4, 5, 6 positives from my model, and what's left are the 4 negatives. And so the difference is negative 4. For number 4, I'm adding, so I'm going to start with 2 positive chips, and I'm going to add on 6 negatives. So I've got 1, 2, 3, 4, 5, and 6 negatives. I can see that I have 2 0 pairs, and what's left are 4 negative chips, so the sum is negative 4. Moving on to number 5, so I'm back to subtraction, and my first integer is a negative 6, so I'm adding 6 negative chips to start. I want to remove 2 positives, and as you can see, I don't have any positives, so I can't remove 2 positives if I don't have them. So you know what that means. I have to add 0 pairs, and specifically 2 0 pairs. I want to have 2 positives that I can remove, but I have to add 2 negatives to cancel those out, so that my model still represents negative 6, the first integer in the problem. But by adding my 0 pairs, I can now remove those 2 positives, and if I count up all of the negative chips that I'm looking at, I have 8 of them, so the difference is negative 8. And last one, number 6, we're adding, so we're starting with a negative 6, so that's 6 shaded chips, and I'm going to add 2 negatives to my model, so plus negative 2. I don't have any 0 pairs here because all of my chips are negative, and if I add them all together, I have 8 of them, so the sum is negative 8. And now they have a couple of questions for us, making some comparisons. So for number 7, it says, how do number 1 and number 2 above compare? What is similar and what is different? So if you look back up to number 1 and number 2, you may have noticed that they have the same answer. So they have the same answer. For number 1, the difference was 2. For number 2, the sum was also 2. What's different about them is that they have different operations. So for number 1, I'm subtracting. Number 2, I'm adding. And the models look different. So for subtraction, I've removed chips, and for addition, I've added chips on. So I'm going to list those two things for my differences. They have different operations. So that's referring to the subtraction and the addition. And the models are different. So for subtraction, we are taking chips away, and for addition, we are adding chips on. They ask us a similar question about number 5 and number 6, how they compare, what is similar and what is different. So we can see the answers for number 5 and number 6 on the screen. We can see that they are the same. So I have a difference of -8 for number 5. I have a sum of -8 for number 6. So they have the same answer. One is a difference, one is a sum, but the value is the same, -8. And again, there are different operations. For number 5, I was subtracting. For number 6, I was adding. And the models look different. For number 5, I have removed chips. For number 6, I have simply added chips on. So they have different operations. And the models are different. Okay, so what they kind of wanted us to see, I'm going to scroll back up so we can see number 5 and number 6. They wanted us to realize that number 5 could be rewritten as an addition expression, and if I were to rewrite it, it would be the same expression as number 6. So as an example, for number 5 here, I can rewrite this as a -6 plus a -2. And now we're looking at the same expression as we see for number 6. And this is why they have the same answer, -8. If I go back to number 3 and number 4, the same is true for these two expressions. So for number 3, I can rewrite this expression as 2 plus -6, which is what we see for number 4, which explains why they have the same answer, -4. And you might be guessing that we can do the same with number 1 and number 2. So for problem number 1, I can rewrite this expression as 5 plus -3. And once again, that's the expression we see for number 2. So this explains why the answers for those two expressions are the same. And so what they want us to put together here is that any subtraction expression can be rewritten as an addition expression. And it's much easier to do the addition mental math and think about a chip model than it is to do subtraction. And so on the next page, 28, they want us to circle the operation that we will be performing, write an equivalent addition expression for each subtraction expression, and then simplify. So they've given us an example. They've got 3 minus 5. So notice that they left the 3 the same, but they rewrote as addition of the opposite. So it's important for us to note that we want to add the opposite when we are rewriting a subtraction expression as an addition expression. Once we have it as an addition expression, we can think to ourselves, these 3 positives will take 3 of those negatives to form 0 pairs, and that's going to leave us with 2 negatives. So our answer is a -2. So for number 9, if I think about adding the opposite, my -2 will stay the same, and I'm going to change this to plus, and then if we circle the operation like they've asked us to do, it makes it clear that that 6 was positive. So if I'm going to add the opposite, I want to add a -6. Now that I've rewritten it as addition, I have 2 negatives and 6 more negatives, so I have 8 negatives altogether. So my answer is -8. For number 10, we're going to rewrite this subtraction expression. My first integer always stays the same, so in this case 9. And now I'm going to change it to add the opposite. So I'm adding a -14 instead of subtracting a +14. Remember that these 9 positives will take 9 of those negatives to form 0 pairs. That will leave us with 5 negatives. So our answer is -5. For number 11, when I rewrite this as addition, my 7 remains unchanged, but I'm going to change this to plus a +4. And of course, 7 positives and 4 positives when I'm adding would be 11 positives. I'm picturing a chip model and hopefully you're picturing it too. For number 12, I'm subtracting and I'm going to start with my -10 and then rewrite this as plus the opposite. So it becomes plus +7 instead of minus -7. Of course, these 7 positives will take 7 negatives away, and that will leave us with 3 negatives. So answer is -3. Number 13 is 12 minus 8. I'm going to change it to 12 plus -8. So again, I'm adding the opposite. These 8 negatives will take 8 of those positives to form 0 pairs, leaving us with 4 positives remaining. Answer is 4. For number 14, we're going to rewrite -5 minus 3 as -5 plus -3. So I leave the first integer alone and I rewrite as adding the opposite. So instead of minus a +3, I'm adding a -3. 5 negatives and 3 negatives are all negatives, so I have -8, no 0 pairs. For number 15, -1 minus -15 will be rewritten as -1 plus +15. I've got one negative, which will steal away one positive to form a 0 pair, and that will leave us with 14 positives. So the answer to both the subtraction expression that we started with and the addition expression that we rewrote, both of them have an answer of 14. And the last one in this table, I've got 6 minus -8. I'm going to leave my 6 alone, and I'm going to rewrite this as plus +8. All positive chips, +6, +8, 14 positives all together if I'm thinking about the chip model, which is very helpful when we're first learning how to add integers. And so I have an answer of 14. Okay, we're going to do 17, 18, 19. We're going to skip the last box on this page. Okay, but I'm going to end this video and start a new one so that we can do 17, 18, 19. We're going to skip to number 23 and we'll do the 2-word problems on the last page. So I'm going to stop this video and you'll have to open the second video for the remainder of this lesson. I'll be right back.